what you call file systems. I want to start with file systems. And I remember lastly, we were discussing on file system. And what we said about file system, we have to look at one thing, security. We have to look at backup. We have to look at recovery. Because if you look at most of the files, if you cannot do some recovery on files, it becomes an issue. Then, if we cannot provide security in folder level, still it becomes an issue. So our case is, why do we need to provide security? And still, why do we need to recover data? Remember, when you provide security on files, we always make sure that files are intact. Maybe you create what you call private access. And this private access is where we say it's only few users who can access that. Or if it is not few users, we have some restriction that is given to these users. So not everybody is supposed to access files. And if you look at most of the security keys that you are supposed to have, one of them is using what you call encryption. And when you use encryption, this is when you say we are providing a method that is what you call the ciphertext, cipher. And when you say ciphertext, it means this is a character that has been converted in a way that maybe the users will not be able to see it, but the only person who is supposed to receive it will be able to see the data. So that is what we mean by the encryption. We always provide what you call password, and I think everybody knows a password, and everything is provided by what you call the file system. And that's why we discuss about the file system. And we're trying to understand that the file system will be able to assist in securing data, will assist in making sure that the data is recoverable, will assist in making sure that whatever we are having is up to date and can be contained within the environment. So that is why we need to look at NTFS, because we said we have FAT, we have FAT32, we have NTFS, NFS, but what we were looking at, we were revolving around NTFS, and we were saying NTFS is the best because of its functionality, efficiency, maybe robustness. Maybe we can look at how we can be able to move the files from one system to another without failures, and we can be able to do some other follow-up of the files. So in this case, let us try to expound on this file system. Let us try to expound on this file system. And the moment you try to expound on this file system, we will be able to look at now NTFS. You understand what is NTFS. And when you try to understand what is NTFS, we will be able to look at NTFS in its own structure. So what is a structure? We understand that a structure is an organization. So a structure is an organization of files. So either we are looking at where we can organize files in a given order. So we are looking order of organization. And when you look at order of organization, that one we said we can use different file systems. Now let us look at this file system in deep. And that's why we are saying it provides combination of performance, reliable. Now, are we having files that are reliable? Are we having reliable files? Then it also provides compatibility, not found in FAT file system. So in this case, we can provide compatibility. And when you look at compatibility, we are looking at a point where files can be accessed in different platforms. It's not a must that you access them in one platform. If you look at FAT, we were only accessing them in one platform. That is Windows. If you go to Linux, it becomes an issue. But if you look at NTFS, NTFS allows you to access them in maybe Linux operating system, maybe in other platform of operating system, and maybe that's why we were saying this is more efficient in terms of access, in terms of performance, in terms of reliability. Then we're looking at now, it is designed to quickly perform standard files operations such as read. So in this case, we are looking at speed. So we can say the speed is high in terms of access. It's not like when you're using what you call FAT. And at this case, we can be able to look at now file access in a more advanced way, So that's why when you look at NTFS, we can now define our own structure that is mostly used in coming up with the right structure in it. And that's why we say that it is a formatted volume. So the whole of this disk, if you look at now, maybe I say I have a disk, and maybe I say this is a disk that I have, and there is a disk that is supposed to be used for access or storage of data. This becomes the formatted. It becomes the formatted disk. That becomes the formatted. So a formatted disk is a disk that you can use in storage of data and in access of some information that we have. So that's why we are saying formatted volume with the NTFS file system result in a creation of several system files and the master file table. The master file table contains informations, and I think we have explained here, it contains information about all the files. It is like when you go to a class, the register contains information about students. How many times have you attended the class? Like now we are taking the online register, which is more vital, which you read to some consequences for those students who are not attending the class. So in this case, we are saying the master file table is the one that is providing now information for our system. And folders on the NTFS file. So it provides information about all the files and folders. And I remember when we are talking about folders, we said these are directories that are supposed to be used within and the NTFS volume. So that's why we are saying the whole of this is the formatted volume. And if it is a formatted volume, it has the master file, or it must have what we are referring here as the master file table, which has all the information. Then the first piece of the information on NTFS volume is the partition boot. So we can say the partition boot, which starts the sector 0 and can be used up to 16 sector long. So it means it is the one that defines how many sectors we are supposed to have on each volume. How many sectors are we supposed to have on each volume? So if I'm having this disk, and this is the disk that I'm supposed to store data, so how many sectors should I have within this? So that one is always catered by what you call the partition boot, or what you call the partition table, or what you call the partition sector. So that's why we are calling it the partition boot sector, which provides sectors from 0 up to that. Like now, when you are looking at disk, there is a time that I said we divide it in tracks. So those tracks are the ones that are now divided into different sectors. So from sector 0 up to the maximum sector that you are supposed to have, that is catered by what you call the partition boot. Then we are saying the file illustration now is this one, which is provided here. And if you can look at this, maybe I try to expand, and I hope you can see it. Yes, you can see it. I can see that. So we are looking at now the partition boot, where we have said the partition boot always provides the sectors, Then you have the master boot, master file table, which provides information. So it provides information. Then we have the system files. When you look at the system files, mostly we are looking at the operating system. So in this case, we are looking at the operating system. Which operating system that we are supposed to use? Maybe if you look at most of the operating systems that we are supposed to use, and that's why we have said this allows you to use it in different levels of operating system. And that's why we can say if you're using it in Linux, maybe you are using XLR 2, XLR 3, maybe we are using CAFs, BAVs, etc. as file systems. So in this case, if you look at now the operating system, you are either looking at Windows operating systems. Windows, we are looking at either Unix operating system. You are either looking at now those operating system, or maybe you are looking at the mobile operating system. Mobile operating system. So if I use Linux, let's say maybe I'm using CentOS. Let's say maybe I'm using CentOS operating system, or I'm using Red Hat, or Fedora, or Ubuntu, or Linux, or Kali Linux, or Kali Linux, or Kali Linux. So even though I'm using these operating systems that I have here, doesn't matter in terms of the file system that you're using, because now the file system that you use here as NTFS is able now to provide these mechanisms of file communicating different level. So the whole of this is one that we are calling the layout of NTFS volume. So this is the first volume, the second volume, the third volume, the fourth volume, etc. So in respect to the executions given to different sectors. So this question is examinable in NEC. So please, can you observe this? Make sure that you observe this, you understand it, and you familiarize with it in a manner that you not have some issues in execution within the processes. And that is why we look at now in partition boot, we have the master file table, the system file, and we have said these are maybe like an operating system. Maybe these are the programming systems or the programming languages that you use, all the system files that we have. Because when you talk about the system files, we always talk about programming files, system files like operating systems, maybe the executions of these processes. Then when you look at the file area, this is where now you provide all the files that you work with. Maybe you are working with file like a document file, Excel file, PDF file. All these are now provided here in the file area within the volume. So that's why I have expounded and saying that in master file table, this one, each file on the NTFS volume is represented by a record in a space show file called the master file table. So it's like now we are saying, if we can be able to provide, maybe using a diagram, is like we are providing a presentation of some information. So we are providing some information like where we can say, maybe here we are having files, and here maybe we can have the file size. We can still have the file type etc. Let's say here I have the file A, which is supposed to take 300 memories. Then we have file B, which is supposed to take 100 memory. The next one is supposed to be CR, which is supposed to take 34 memories. And maybe we have E, which is supposed to take maybe 23 memory. So this is now a table, which is a master file table, and where we can still allocate, maybe try to create where the file will be allocated, try to create where maybe the file type, maybe we can say we have the file type, this is a PDF, this is a document, etc. So it always provides these informations, looking at various attributes that we discussed previously in our class. And we saying those attributes can be used in the data presentation So that's why we are saying NTFS reserves the first 16 records of the table for the special information. The first record of the table describes the master file table itself, followed by the master file table mirror record. So mirror record is the one that provides what you call duplicated files. Duplicated files. If the first MTFS file is corrupt, means the second. So that's why we find that now if the record is not correct, we can now move to the next record. That's why we need to do what you call disk defragmentation every time. And I think maybe we can look at maybe whether we can see disk defragmentation, disk defragment optimization. And this is the process of doing that. Maybe we can type disk defragmentation, you go to optimize. We look at this, maybe we can try to analyze that. We can see 21% analyze, maybe we analyze up to the maximum of what you call the 100% needs optimized optimization, where 11% fragmented. Now that's why we do what you call defragmentation. You find that when you're doing defragmentation, you consolidate files together. Meaning if there is a fault file, you can be able to see it somewhere. So this one is provided in what you call the master file table. And if you look at now, I can optimize this. And when you try to optimize, it is giving you percentage. And that's why if you can optimize your drive to help your computer run more efficiently or analyze them to find out if they need to be optimized. So why am I doing this? I'm doing this because I want to make my disk more fast in execution. So when I do that, remember that we have said, if you look at what we have said here, we have said in NTFS, that is NTFS master file table, we need to do what you call mirroring file. We mirror file. And we can still create what you call the mirror record. So you need to optimize so that we can speed up the execution. And to me, I have already optimized, and there is one pass already. There is pass one already, where now it is already 30% relocated. So you are relocating it. Maybe I can present it with a diagram. If you are assuming that this is the allocation of these files, and you find that these files has already been allocated somewhere here. If you allocate a file here, then you allocate a file here, then another one here. What about these two? So that's why we are relocating. And when you try to relocate, our end result will be, suppose we are having the same or equal measurement. So this one will be allocated here. We relocate here. We relocate here. Then these ones we push to the end. So we are pushing these to the end for easy allocation of other processes that we can have within the execution. So in this case, that's why we can say we have tried to speed up the execution. That's why you can see this processing that we are having here. So you can see this, what it's done here. We are trying to relocate files. We are trying to parse them. Maybe if I still need to do this, so 0% defragmented, maybe we can stop that. We still optimize if you want to. So we can arise. If you move from there, you do away with the defragmentation. And I want to take you back maybe to ICT. The moment we are discussing ICT, there is a point that you said defragmentation is bringing the files together and taking away the holes away from the allocations. So in this case, that is what we are doing here. We are reallocating them, and we are relocating them to a separate allocation. So at least my computer can speed up the execution. and can be able to improve speed when doing some process execution. It's like now, if you go to your room and you find that you have very many rooms, but they are not organized. So automatically, we will have to create some maybe nuisance within them, where sometimes you have some accident for those people who are passing through the rooms. Maybe we have some issue. Maybe we have some other maybe queer animals that are living in your home because you have not organized. The same case to this. And that's why you can see all the process has been optimized, and we are still trying to relocate them. So pass to, we have already passed to. Meaning when you say pass to, there are two files that has already been relocated from one point to another in the execution. So that is now what you are trying to look at in the process execution. So I think now you are understanding. Is there any question up to that point? Maybe you can raise some issues on or maybe how to come up with optimization. So let's have some question for. So I'm waiting for the question, please.
I have a question.
You can ask a question, Michelle.
Oh,
I'm listening.
you have said what's defragmentation?
Oh, fragmentation. I have said that fragmentation is when files are not organized in a contiguous manner. Like now, if I present maybe using a simple diagram here, maybe let me use paint. Suppose now, you remember we said in a memory, either you are using a disk or anything else, we organize memories into arrays. I think that one is not new now. So in this case, we are saying if this one is where the operating system is, we organize the file here. The moment you store files, you save file, but you don't know where you are saving it. Suppose now the first memory is this, the next memory is this. Then you find that now maybe you have another memory here, and this one is now the next one. If these two memories are not allocated, now the question is, do we have some faults in these memory allocations? What is the issue? So in this case, you find that the files have been fragmented. They are not contiguously arranged. Meaning, if this is now the allocation that you are supposed to allocate files, and we need to allocate file, you allocate file here, you allocate file here, you allocate file. So this is now contiguous. This is contiguous. And if it is contiguous, these files are not fragmented. So fragmented is when files are not close to each other. They are dispatched away from each other. Am I clear?
Yes.
And that's why we need to do what you call defragmentation. And if you look at my system, the system that I'm running here, in this case, we have 43% defragmented files. Remember, for each and every day that you try to execute, like now, if I try to give you the files that are executing, just go to run, then you type percentage temp, then percentage, then you present OK. If you look at these are all files that has already been executed and they are taking memory. These are temporary files and they are taking a lot of memory. If you look at this, maybe, I don't know whether we can see the size. Maybe let's see the properties. If you can look at the size, we have size of 11.7 MB. which is a rot. So what we do, we just delete. We shift delete. When we shift delete, we are deleting everything, but we are not storing it in is it called dustbin? I don't know whether I'm right. Recycle bin, sorry. It is called recycle bin. So you're not taking file in recycle bin. When you take files in recycle bin, my friend, we have some issue. That's why you always delete files that are in recycle bin to make sure that your computer can be able to speed up the execution. So in this case, to me, I have deleted everything in my dustbin, and I have deleted all the temporary files. So you find that now, if I try to type run again, and then I go to temp, these are the files that has failed to delete. Maybe we have some issue. Let me try to delete one by one. So you find that now, this is taking a lot of memory. Okay, we can assume we have deleted many GBs there, many MBs. So my computer is now executing at a very high speed, remembering that I have still fragmented files. And you see there is a one that is written consolidated. Can you see that one written consolidated? Can you see it?
Yes.
Yes. So that one that is called consolidated means those files that you can group them together, they are grouped together. Those files that cannot be grouped together, they are now pushed, they are defragmented, meaning we are trying to optimize the system. And why are we optimizing C? We are optimizing C because C is the one that is now carrying all the relevant details of the system that you have. This is where we have the operating system. Because we try to consolidate the operating system. So in this case, we can try to improve the execution. We can try to improve the execution. And when you try to improve the execution, one, we are improving speed. We are improving the mechanisms of file allocation. Remember now, if we had some faults in the execution, and I remember there is a time, maybe if you go to PC, maybe you go to manage. If you go to PC, then you go to manage. Just a minute. If you look at now the performance, don't know whether it will, okay. Open the source monitor. If you look at the performance, at least you have tried to speed up the execution of this. Okay. Let's look at the highest time for these disks. So can you see the response time has already improved? The memory compression is 19. When you look at the memory compression, it is because you are doing what you call defragmentation. That's why the memory is having a high speed. If you look at Chrome, this is given as 0. These are the memories that are not utilized currently. And if you look at now the chart that is given here, you can see the CPU is having a consistent flow because of the speed. If you look at now the disk, because we are doing some defragmentation, we don't have consistency. The wavelength is at a very high speed. If you look at the network, we are using it at a high speed in that. So what we can say is that in the execution, we have tried to improve some speed because of the files that we have tried to delete within the execution. We have tried to improve the speed in the execution. So you can see there are some processes that has been suspended by the CPU, and one of the processes that has been suspended is this. So these ones that I'm writing, one we have what you call the shell experience host. We are not using the command prompt. Let's say maybe use the CMD. Maybe connect, try to unsuspend the process. In the execution. Just a minute. Can we have a question? Maybe up to that.
Yes, I have a question.
We nijibu.
Ah,
Nijibu hapa kwa text.
kwani muda ameenda wapi?
Sijui simu yake ilikuwa inalia.
Uko unasemaje?
Hizo kuku. Kumbe wewe ndo mtu wa kuku hapo.
So can we proceed now? Any
Yeah.
question? I'm waiting for a question. So, or we can proceed. Yes.
Can you defragment a disk using the NTFS after fragmentation?
Can you defragment what?
The disk using the NTFS?
Yes, currently it depends with the file system that you are using in your operating system. And that's why we said most of the current operating system, they are using NTFS file system. So currently, we are defragmenting, whatever it's now providing that defragmentation is the NTFS. Is that clear?
Okay.
So it depends with the operating system that you are. If you are using FAT32, let's say maybe you are using the older operating system like 386 series, which was using FAT. So automatically that is that cannot allow defragmentation. So for this case, it is allowing defragmentation because we are using NTFS. Am I okay now?
Yes, yes.
Okay. So is there any other question? We proceed. So I think now what we have said is that NTFS has some provision of these things that we have here, encryption, disk quarters, repass points, and then we have the volume amount point or the volume mount points. And if you look at now repass point, reverse point can only be applied in folders level. And that's why if you look at the files that you always create, you can be able to create some files and you create folders within them. So that is what you call the reverse points within the file systems. So it means that you can be able to add many files. You can provide the access of many files within that folder or within that directory that we have. So if you look at the NTFS, whatever we have been looking at is now the master file table, which is providing everything on that. And it can always use the NTFS file attributes, which are provided. And I think most of the file attributes that we talked about, we have the file name, file type, and many other that you have. Then it is able to provide encryption, where we have said encryption is providing over encrypted data. And the encrypted data is where we always look at a point where the file can be accessed into a separate sections, meaning that each and every one has been enciphered. So I'm talking about this one, ciphertext. Ciphertext. When you provide a ciphertext is where maybe I have the word 3, I provide that with maybe these asterisks. It's like now when you are creating your own password. So either using what you call symmetrical encrypting or asymmetrical encrypting. And when you use asymmetrical encryption, is where if you encrypt using a certain procedure, you decrypt using another procedure. But if you use symmetrical, if now the sender encrypt using a certain procedure, the receiver will decrypt using the same procedure. So that is now the forum that is given on that. So in this case, we have tried to make sure that now the NTFS is able to provide encryption, and that's why we can use it in a network environment and many other environments that we have. Then we have the sparse files. Remember, it is able to create large files, large disk space, etc., and many other that we have. So that is about the NTFS. And if you can look at what we said last week, we said we need to expound on NTFS because it's the one that is providing the access in network environment, many access in various platforms that we have within the system. So up to that point, I want to rest at that point. Unless there is a question, maybe you can ask. The next lesson, we'll be able to discuss on security within the operating system or security within these file systems that we have. Then we still look at now the way we can be able to talk about the access using maybe this platform or this security password, maybe encryption, and then you look at the emerging trends of the operating system that we have. So if there is a question, maybe you can ask. And after this, I have said we will have our cut tomorrow. That's what we have agreed. And our cut will start from 8 a.m. and it will be 1 hour. I have already posted that card, but you cannot access it. And I think you have seen it. It is hidden from you. I will open it tomorrow so that now we can be able to access it tomorrow at 8 and we do that card. So please tell your friends to do that card. Remember that card, we are supposed to send marks to NEC. And if you score a 0 and you are not attending a class, I will not have grace. But if you are attending my class, I can give you a makeup card if you get a 0. And I'm not expecting anybody who has been attending my class to get a 0. So please, after this, we are supposed to go to the chat room. There is a quiz that I will set there. You give me 2 minutes, I set it. Then after that, you'll have a chat room. Don't go after you complete your card. After you complete, go to the chat room so that we can be able to chat 2 or 3 things. So any question? Any question?
The cut.
Yes?
Yes, I have a question.
Yes.
Nilikuwa nauliza cut tuna set kuanzia wapi ama ni yote tu hivyo?
It's good you read from scratch, from the first topic to the last, because I have mixed up some questions. But mostly I'm testing from files. So I will be testing from files and some few questions from memory and few questions from process management.
Okay.
Yes. So for now, because you are doing your exam on July, I expect you to have read everything. You know, at least you know something from chapter 1 up to the last chapter that we are discussing currently. And remember that we are supposed to discuss, and maybe I hope you are praying, maybe we can go back, we have face-to-face communication. And then we will be using our past papers the moment we complete our syllabus. Can we go to the chat room? Any question? Michelle, do you have a question?
No.
Ruto, I think you have. We have communicated. Do you have another question?
No.
Ezekiel.
No, I'm good.
Okay. So can we go to the chat room? We do a quiz there.
Yeah.
Yeah.
Yes. So let's meet there and we do a chat after that.
Okay.